All right, so here we are with 3.11 part B, solving systems by graphing. So this is the second example for graphing. So we have the instructions, solve the following system graphically. All right, now remember, if on an exam or something, I ask you to solve graphically and you choose another method, you will not receive the points for this problem. So please follow the method that is indicated. All right, so I do see one error on this real quick. Can I change that? That should be 3y. Awesome. All right, so we have a system. Remember, a system is when we're trying to solve two equations. In our case, these are linear equations, so they graph lines. So what is our plan? Well, this is the same plan as last time. Step one, we're going to graph the first line, entirely graph it, and then we'll move on to the next line. So how do we graph a line? Well, we need three pieces of information: the X-intercept, the Y-intercept, and the slope. That's how you graph a line. Okay, so let's go ahead and find those pieces of information for our line. And let's call this one the red line. Okay, so the first line, x equals negative 2y plus 9. All right, so how do we find the x-intercept? Go ahead, pause the video, see if you can find the x-intercept. All right, so for the x-intercept, remember we need to indicate them as a coordinate point. To find the x-intercept, you set y equal to 0. Let's go ahead and do that using our equation. 2 times 0 plus 9. X is going to equal, well, that goes to 0. 0 plus 9, and then x equals 9. So that is my x-intercept. 9, 0. Let's go ahead and see if we can find that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, kind of off my paper there a little. 9, 0. All right. So that's my x-intercept. How do we find y-intercepts? Go ahead and pause the video. Try to find the y-intercept. All right, for the y-intercept, we set x to 0. And we use the same equation right here. So 0 equals negative 2y plus 9. 0 equals negative 2y plus 9. I just rewrote that. Okay, so we're trying to solve for y. To do that, we need to get y by itself. So let's minus the 9 from both sides. And then we have negative 9 equals negative 2y. Okay, to get y by itself, let's divide both sides by negative 2. All right, negative divided by negative, remember that's a positive. So then we have 9 over 2 equals y. And what is 9 divided by 2? Well, we can do the long division on that if you want to. Here, let's figure that out. Thankfully, we do have calculators for this class, but if not, let's try it by hand. So 9 over 2, what does that become? So 2 into 9. How many times can 2 go into 9? 4 times. Minus 8, that's a 1, so it's going to be 4.5. So 4.5. So 4.5 equals y. So my y-intercept is 0, 4.5. Let's go ahead and plot that. 0, 4.5, 1, 2, 3, 4.5. All right, we're almost done graphing the first line. What is the other piece of information we need? The slope. And remember, the slope is not a point. It tells you how you get from one point to the other, or it's the way your line is decreasing or increasing. So why do we want the slope? We want the slope so we can find the third point we're looking for. Remember, we just have 2 points. And I want you to have at least 3 points when you graph your line. So the slope is a good way to find the third point. Okay, so how do we find slope? Well, remember, we're going to use the equation y equals mx plus b. That's how we find slope. It is the number by x. So let's take a look at our equation. X equals negative 2y plus 9. Is that in slope-intercept form? No, it's not. The y is not by itself. So our goal is to get y by itself. So let's subtract 9 from both sides. Then we have x minus 9 equals negative 2y. Well, y is almost by itself, so let's divide by the negative 2. Okay, let's see what this looks like. We have negative 1 over 2x, negative divided by a negative. Sorry, negative divided by negative is going to be a positive 9 over 2. Y. Okay, and rewriting this so it looks like what we're used to, this is y equals negative 1 over 2x plus 9 over 2. So our slope, remember the slope is the value by x. So that is negative half. Which means, and remember, you choose if you want the negative to go with the top number or the bottom number. So I'm going to choose the negative to go with the top number, which means for our directions, we're going to go down 1 and right 2. So the problem with this, though, is if I chose this point, I'd be going down and off the page. So we could do that method, or if we chose the negative to go with the 2, for example, this means it'd be going up 1 and back 2. So remember, either versions of these with the slope works. You can choose to have the negative with the top or the negative with the bottom. Okay, so I'm going to go ahead and plot that. I'll choose to pick this point to count my slope with. You could choose the other point. I'm going to choose this point. So we go up 1, back 2. And there's my other point. So now I have 3 points. I can go ahead and draw my line in. Let's see. Oh, good. The dots line up. Please remember your arrowheads. Arrowheads are important. Let me draw that line out a little bit more. There we go. Okay, we're halfway there. We've got one of the lines done. Okay, so go ahead and pause the video, see if you can graph the other line. All right, so let's go ahead and find the 3 pieces of information for my other line. See if we have room here. So the second line. I'm just going to go through this one because we've already done an example. So my second line, my second line is x equals 3y minus 11. I'll call this one the blue line. Let's see. First thing, X-Intercept. Okay, so we're going to set y to 0. So x equals 3 times 0 minus 11. So x equals negative 11. So I'll go ahead and plot that point. 1, 2, 3, 4, 5, 6, 7, 8. Got to do more spaces. 9, 10, 11. There we go. Hand drawn graph. I can get away with it. All right. Let's go ahead and find the Y-intercept. The Y-intercept, remember we set x to 0. So we have 0 equals 3y minus 11. Let's go ahead and once again solve for y. So let's add 11 to both sides. That cancels that out, and we're left with 11 equals 3y. Solving for y, divide both sides by 3. And we have 11 over 3. So let's go ahead and figure out what that would be as a decimal. If you don't have your calculator. If you have your calculator, you can go ahead and plop that in. So 11 over 3 is 11 divided by 3. 3 can go to 11 3 times. Minus 3, sorry, minus 9. We're left with 9, 2. So 3 and 2 thirds. Okay, so graphing that, let's see, 0 and 3, 1, 2, 3, and 2 thirds is about almost all the way to 4. Okay, so we've got 2 points. Remember, we need 3, so that means we need to go ahead and find our slope, which we can use to find the third point. So for slope, we need to get it into y equals mx plus b form, which means we're going to solve for y. So, isolating y, we'll add 11 to both sides. X plus 11 equals 3y. I will move my work up here. x plus 11 equals 3y. Getting y by itself, let's divide both sides by 3. So I have 1 over 3x plus 11 over 3 equals y. And I'll rewrite this in a way you guys recognize. Y equals 1 over 3x plus 11 over 3. Remember, because it's an equation, if you flop the sides of the equation, it does not matter. Both sides are equal to each other. So what would my slope be? Well, it's the number by x, which is 1/3 equals m. Oh, I forgot to do that on the top. Shame on me. Slope equals m. Ooh, I can't really fit that. There. Okay, so let's go ahead and use that to count up our slope. So for the slope of 1 over 3, we're going to go up 1 and right 3. So I'm going to choose to go from this point. Up 1, right 3. 1, 2, 3. Okay, let's go ahead and draw that line in. My arrowheads, important. All right, so remember, what were we doing? We were trying to solve a linear system. So the solution to a linear system is what? It's where they intersect. It's where the two lines intersect. So where do these two lines intersect? It's at that point right here, which looks like 1, 4. So my solution is the point 1, 4. And there we go. You've solved a linear system graphically. So the one thing about graphing is that the nice thing about this is that was an exact answer, 1, 4. But what if my answer was actually going to end up being a decimal? What if they intersected somewhere weird like this where I wasn't certain if it was a half or a fourth or something? So because graphing doesn't always work well, we wanted to have other methods. So the other methods are the ones that are going to be introduced in the next video, the elimination method and the substitution method.